Okay, this is one of the chapters that you really need to spend a little bit more time than you have in the past, because there are lots of concepts we will do in this chapter. If you understand all the concepts that I'm trying to explain to you, then the chapter will flow very easily. However, if you decide that you want to memorize without understanding what's going on, it's going to be a little bit more struggle. So let's begin with the first statement that's in this chapter, and that is about octet rule. Now, previously we did a lot of configuration for the electrons, and we saw how the electrons were arranged in the orbital shell or the cloud which is surrounding the nucleus. In this chapter, the focus is on the octet rule, which states that in order for an element to be stable, it must follow the noble gas in its periodical row or in series. And all noble gases have 8 electrons in its outermost shell, except helium. Now, why is helium with only 2? If you can remember, or if you look on the periodic table, you find that the atomic number for helium is 2, which indicates that it has 2 protons and 2 electrons. So it is filled in the first shell. However, all of the other noble gases, for example, neon that has atomic number of 10, 2 in the first shell, 8 in the second shell, indicates that the outer shell has 8. Argon, 2 in the first shell, 8 in the second shell, and 8 again in the third shell, indicating 8 as the outermost shell, and so for hence for the other. So 8 is pretty much the maximum number of electrons that an orbit or a shell can hold. Now, once you've understood this, and when you go to chemistries in the next level, you will go a little bit more depth about this, and you will understand the concept of orbital much better. But for simplicity, we will go with this model of 2888. So this indicates if this was the nucleus, then it's going to be surrounded by 8 electrons. And if you can remember this octet rule, it becomes very easy. The rules that applies to the helium is sometimes referred as a duet because there's only 2 electrons. However, we will talk about a octet most of the time. So in order for an atom to have 8 in its outermost shell and to become stable, it has 3 options. Option number 1 is to either lose the electrons. For example, if this is an atom that has 2 in the first shell, 8 in the second shell, and 1 in the outer shell, then if it lost this 1 electron, if it's gone, it can get the configuration of 8. However, notice what's happened. From 3 shell, it got down to 2. So sort of its atomic radius is going to be decreased. However, if there is an atom that has 2 in the first shell, 8 in the second, and perhaps, let's say, 6 in the outermost shell. Now, in order to reach an octet, it must have the outer shell should be 8. So for this atom to lose these 6 electrons will require a tremendous amount of energy compared to the one above, which is shown up here. The atom on the first category only has 1, so it will require less energy. So what happens is atoms are pretty smart. They don't want to save energy. The one on the top will actually lose, and the one on the bottom will actually gain. By gaining, it will need to have 8 in the outer shell. So if you notice, if it has 6 in the outer shell currently and it needs to have 8, it must gain 2 more electrons. So it must gain plus 2 electrons to have 8 in the outer shell. Does that make sense to you? So some atoms will actually either lose, some will gain. However, What about an atom that has 2 in the first shell, 8 in the second shell, and perhaps only 4 in the outer shell? It can either gain or lose. It sometimes will share. And we'll see a lot of sharing between certain types of elements and not the others and so forth. So based on the concept about how to get 8 electrons in the outermost shell, we say that atoms will follow this octet rule to form 2 main kinds of bond. One kind is called as ionic bond. Second kind is called as covalent bond. In this picture over here, the first picture over here is representing an ionic bond. So let's see what's happening up here. Notice the element which is in blue is written M, which indicates that it is a metal, and the yellow is the non-metal. Now, 1 dot represents 1 electron, 7 dots represent 7 electrons. In this scenario, this atom, which is the metal, is losing and giving its electron to the non-metal. So what happened to it? If it just lost one negative charge, which remember electrons are negatively charged particles, and if you recall, let's go back and remind you that number of protons equals the numbers of electrons. Protons are positive in number. Electrons are negative in number. So if this metal just lost its electron, it is now 1 less negative charge because it has 1 less of those negative charge. So the sum would be more positive gain. So it is called as an ion which has a positively charged particle. On the other hand, this non-metal had 7 electrons previously, and now gaining that 1 has actually increased its negatively charged, so it becomes a negatively charged ion. These two are charged particles. So an ion is basically a charged particle. A charged particle indicates that it has a charge on it, and the charged particles are called as let's see, what happened? My pen, I thought I got it. Okay, I'm just going to ignore that right now. Again, I think my mouse is giving me a little bit of trouble. The charged particle is going to be a positively charged particle. Having a little trouble today. Let's see. Let me just stop the. Okay. So the charged particle is called as the ion, and an attraction between a positive charged particle and a negative charged particle results in what is called as an ionic bond. On the other hand, the other kind of bond that is shown in the second image over here is an example of where you see that there are 2 non-metals. Notice they're both non-metals, and they have 1 electrons on both sides, which is being shared. So when it gets closer and it shares, notice over here there's a little bit of overlap, which indicates that these atoms are very close to each other, and they're sharing these 2 electrons, which results in completing the octet, which is 8 electrons, the concept of 8 electrons. So you have 2, 4, 6, 8. So actually this one's missing a dot over here. Let me put a dot over here. It's missing these tiny dots. Come on. Kind of hard to draw with a little mouse, and you want to get it straight. Anyway, so here is our here is the covalent bond that is shown, which is forming between 2 non-metals. So there's a lot of information on this picture. Firstly, it gives you the information that ionic bonds are between metals and non-metals, covalent between non-metals and non-metals. In ionic form, as the name indicates, ions are formed, and then ions are attracted because of oppositely charged particles. Non-metals, however, share, and they share an electron cloud. We're going to reinforce this concept over and over again today, so hopefully you'll get it. So let's look at the metals forming the positive ions in a little bit more depth on what I was previously mentioning. Metals form positive ions. Always remember that. Here is an example. You've got sodium atoms has 11 electrons, 2 in the first shell, 8 in the second, and 1 in the last. When it just lost this 1 electron, it has less negative charge. So from 11 electrons, it has now 10 electrons. However, it still has 11 protons. So the net charge on this ion is a positive charge. It has one more positive charge. So you will find that all metals that are in group 1 have something in common, and that is they have a charge of 1 plus. All atoms in group 2A, which are also metals, have a charge of 2 plus. All atoms in group 3 will have 3 electrons, so it will lose those 3 to form a 3 plus charge. Isn't this interesting that the atoms, the elements that we saw earlier, the way they were placed in the periodic table, and the group numbers are, which earlier I told you, explained what is a valence number, is actually also their charge number. So sodium has a charge of 1 plus. Let's look at magnesium. Magnesium has 12 electrons, so 2, 8, and 2. It just lost, losing its 2 electron. It now has 10 electrons, so the net gain is 2 plus, because it has plus 2 more positive charge. No algebra here. A lot of people get mixed up later on and they'll ask me, well, how is it, if it's losing electrons, why is it plus? Again, no algebra here. We're talking about the charges. If you have more of the positive charge versus less of the negative charge, the total charge is positive. So always remember, metals will always form the positive ions, and these positive ions are called as cations. So the positive ions are your cation. Cation always indicates positive ions. Next, we will see what there are another kind of ions that atoms can also form, and those are the anions or the negative ions. I remind students that if you don't know which ones are which, then go with the word a negative ion or a anions, and the other ones will be the positive ions. An example, we will look at a non-metal. For example, chlorine. Chlorine has 17 electrons, so here's an electronic configuration. First shell has 2, second shell has 8, and 7 in the outer shell. So it needs to have, to complete its octet, it needs to have 1 more electron. So it gains that electron to achieve the octet arrangement. And now since it has gained 1 electron, so the sum total of the protons and electrons have changed, and now it has 1 excess negative charge. So the total charge would then be represented as 1 negative. Now at this time I want to reinforce that non-metals, that were everything on the right of the zigzag line, will always form negative ions, and everything that was on the left of the zigzag line will form positive ions. So for example, an ionic compound is a compound that consists of positive and negative ions. In other words, positive ions are coming from your metals. Negative ions are coming from your non-metals. So a combination of metal and non-metal will result in an ionic compounds. Ionic bonds are attraction between positive and negative charged ions, which are the charged particles. Ionic compounds generally have high melting point, high boiling points, and generally are also solid at room temperature. Here is an example of one that you might be more familiar of, which is the table salt. The name is sodium chloride. Now, why do we write the way the formulas are? Now, the formulas of any ionic compound pretty much indicates the ratio between the two atoms. So, for example, over here we see sodium and chlorine, and there is no subscript written next to it, so it seems like the ratio is 1:1. Now, how does this form? I want to give you the cross your heart method. So, for example, sodium has 1 positive charge, chlorine has 1 negative charge, and it's also depicted over here in this image where we have 1 dot and 7 dots. So if this is going to give this away, you have positive and negative charge. So how did it all complete? It completed because 1 electron was given to here, and if you actually think of it this way, the total charges in the end are balancing, 1 positive to 1 negative. So the rule that I would ask you to remember is you take this number and cross it to the other end. So it will give you the ratio between the two atoms. It will be 1:1. So a sodium atom loses its valence electron, chlorine gains it. The symbol of the metal is written first, always, followed by the symbol of the non-metal. If you can remember these rules, you will be very happy in class. Okay, let's look at magnesium chloride. Now, why do we write 2 with magnesium chloride? Now, notice magnesium, I'm going to use my cross your heart method. Magnesium has an ionic charge of 2+. Why? If you remember, it has 2 extra electrons. It just gave it away. And chlorine, we saw, had 1 negative charge. So in order to have a neutral molecule between these two, you would have to, let's show you what I'm trying to do here. You will have to have 1 chlorine atom to 1 magnesium atom to 2 chlorine atoms. Does that make sense? Because magnesium is losing 2 electrons. So if it's losing 2 electrons, it must be gained by 2 chlorine atoms. So the total formula would be MgCl2. And this is the way that I would recommend that in class you follow the cross your heart method. And it will be easier to name all ionic compounds in this pattern. On the bottom over here, there's an example between sodium and sulfur. Notice there are 2 sodiums to 1 sulfur. So we did the cross your heart method. If I do the cross your heart thing over here, then Na is 1+ and sulfur is 2 negative. If I cross my numbers, my formula would be Na2S. So using this cross your heart method, you will be able to depict formulas of many compounds that we will be doing within this class. Okay, here are some other examples. Actually, we have done this one. Okay, let's look at another examples of sodium and nitrogen. Using the cross your heart method, charge balances is used to write formulas for sodium nitride, a compound containing sodium and nitrogen. So notice over here, what do we show? We can see over here that we have 3 sodium ions to each nitrogen ion. Does that make sense to you? Why would we have that way? So if you think of it with the cross your heart method, it becomes a lot easier to predict that. So for example, if I was to write Na and I put down the charge plus and I write down N3 negative, let's just write down. And with your cross your heart method, it just makes it a lot easier to come up with the ratio between the two atoms and in order to have a neutral charge. So this means that there should be 3 sodiums for 1 nitrogen. We'll do an activity 1 in class based on this method. So I'm hoping that you will get a little bit more practice. Now let's do the same thing with the barium and the chloride. Notice barium has 2 plus because it's in group 2. Chlorine is in group 1. To balance the two charges, we need to have 1 barium to 2 chlorine. So if you do the cross your heart method, you come up with the right formula. So let's look at another example of potassium sulfide. Identify the cation and the anion. Potassium is your positive ion, so it's going to form the positively charged ion. This is an example when you have a name given and you have to come up with the formula. So you write down potassium. The next thing you want to do is look in the periodic table to find which group number is potassium present in. And you will find that potassium is present in group 1, which indicates that it should have 1 plus charge or the ionic charge. A sulfur, on the other hand, is present in group 6. So elements that are present in group 6 have a negative, it needs 2 more electrons. So that means it will be 2 negative. So we have potassium, which is 1 plus, sulfur, which is 2 plus, and if I do the cross your heart method, I come up with the formula of KS2. You will find that metals always have charges of +1, +2, +3, and non-metals will always have -3, -2, and -1. I think I missed mentioning this to you over here in this slide. Well, no, this is the slide for the metals. Let's see. I think I'm missing a slide. Let's see. Yeah, I think I missed attaching a slide, so I'm going to go ahead and explain it to you up here, which is the negative charge one. Let's go and find this. Yes. Negatively charged ions are always present in group 5, 6, and 7. So group elements, actually I have a periodic table that I can see that it's present over here. I want to use this. No, this is also not the right kind. Okay, we're going to go back and just explain, stay on this slide. Elements that are present in group 5 have 5 electrons in its outermost shell. So that indicates that if you have 5 electrons, in order to find 8 in the outermost shell, your charge should be a -3. Elements that have, for example, that are present in group 6 will have 6 electrons, and they will need 2 more electrons, so their charge would be -2. So here I've drawn you something that's present, for example, in group 5, which is nitrogen. So nitrogen being present in group 5 has 5 electrons, so it needs 3 more. So the charge on nitrogen would then be 3 negative. The charge for oxygen, which is present in group 6, has 6 electrons. It needs 2 more, so it would be 2 negative. And chlorine that is present in group 7 will have a charge of 1 negative. So you will always have values of 1, 2, and 3 for the metals, 1 plus, 2 plus, 3 plus, and for the non-metals, -3, -2, and -1. So one of the things that you have to learn is, given a name, how do you come up with its formula? So here's a name that's given to you, potassium sulfide. And we want to know what the formula is. So firstly, you need to know which is the cation, which is the anion. Potassium is the cation, sulfur is the anion. So once we know that, then we need to learn, we need to know where, what is the group number, so we can assign positive and negative charges to it, as you can see over here. And then you do the cross your heart thing, and when you do the cross your heart, then you come up with this formula as K2S. So that would be the formula of this compound potassium sulfide, and we'll get into the naming in a little bit. Now, naming elements with actually, we're going to take a break now, and because this lecture is pretty long anyway, so we're going to take a little break here, and then we'll go on in the next part.